Okay, and we'll move this out of the way and we'll close down our Jupyter Notebook. Now we will run our app again just so we can remember where we're up to. Looks pretty good. Sweet. So now we're going to make our spectrogram. So we'll look at our project structure. We're going to make a new file, app/spec.py. We had inside of our wave, we had this orthographic function. We're going to stick that. We're going to stick that in our utils file. So we'll stick that down here. Grab our two functions. I don't like using spaces, I use tabs. It's just my style. Now the height, we come back here. Where is it? Okay, so yeah, here we go. So our y, our image height, or the height of our XDB, is exactly 513. And the reason for that is the fast Fourier transform has a window size of 1024, and it effectively halves that. It throws away roughly half the data. And we're left with a height that is exactly half, which is 512 plus 1. So this is where we get this 513 from. So we need our texture to be also have a height of 113, and then the width is going to be just the width of the window, which we're going to give it, which is going to be self.width, and then the number of channels. So that's where we get that number from. We're shifting our frame over to the left in exactly the same way that we did with our audio wave. Okay, so now we want to import that into our main class. Hopefully we didn't make any mistakes, but almost certainly did. I can see one mistake already. got to be big. And another one here, config, because we copied that over. And a quick check. Looks pretty good. So we'll save that and we'll open up our main. Not that. Our main. And we'll have to import it right here. Import our spec, and then we'll load it up in exactly the same way as we did our wave. And yeah, we're going to drop this size of this one down back to 200. And the y, we're just going to give it the self.wave.height. So that way it's going to start at the bottom of the wave always, no matter what size it is. And this we're going to give a size of, or a height of 460. And a size, we need to add that here as well. And add it to our spec. We're going to update our spec. And then we need to draw our spec as well. And that should do it. Give it a go. Save and run. Yep. Okay, there's, yep, little error there on 109 in spec. So go back to spec and then just jump straight to 109 right there. Get rid of that W. It might be the only error. Wow. No, of course not. Slice 102. Oh, yeah. Okay, so if it's not none, they're going to create a slice. If it is none, then we're going to say slice is equal to self.slice, just for now. Hey, okay. So another error here on 104. I'm not broadcasting a shape correctly. That is that's because silly. There was always going to be a million errors. Okay. Wow. Okay. That is not working the way that it should be working. Okay, why is that? It's moving way too fast, for one, and it's weirdly broken. All right, I'm gonna have to. It's gonna have to take me. It's gonna have to give me a second to figure out what's going on here. Again. Okay. What could be causing that? It doesn't make any sense. Ah, that's why. I've mixed up these two. So the width is supposed to be the width. So it's width and height, not height or width. Okay. Okay, should work now. There we go. Okay, so as I'm speaking, you can see that the wave and the spikes in the audio here and the spectrogram highlight at exactly the same time. Well, roughly speaking, like you can definitely see there's a correlation between these two things. You know what I mean? It's not an accident. They definitely are, working together. And that's what we wanted. Now, the only bad thing about this is that the microphone that I'm using is it seems to have a lot of background noise, a lot of like feedback or something like that. That's why it's lit up like a Christmas tree. But apart from that, it's looking pretty fantastic. We can definitely see, as we're speaking, or as I'm speaking, that we're getting the spectrogram, like we're getting the spectrographic representation of the audio as well as the audio wave, and it looks absolutely amazing. So that's the bulk of what we needed to do. Now the rest what we need to do, we need to add time and frequency axis. So we need time axis along the bottom and then a frequency axis along the Y. But that's pretty much the bulk of what we needed to do. So, you know, we're in the home stretch now. We will get back to that. And I'll see you in the next one. Okay, home stretch. So first thing, so we noticed earlier that our spectrogram is lit up like a Christmas tree. It is way, way too bright for my liking. So how we're going to deal with that is something we already implemented. So we'll go to our app/spec and see these min-dB, max-dB. That range that we basically we want to clip out, which we do here. We clip out anything that is less than or greater than that range. So let's try a range that starts from -40 decibels instead. And let's see if that is less bright or less overwhelming. Okay. It's definitely better, as we can see. So the background, it only has a little bit of, you know, a little bit of noise here in this background. And so different microphones and different volumes and different, you know, amounts of feedback and all this sort of stuff, songs that have, you know, the volume slightly more or slightly less, they probably will saturate in different ways. And so this is why I provided the ability to set this range or clip out this range. And it, you know, as you can already see, we've definitely got a much clearer signal here. I'm going to adjust it a little bit more, and I think that'll make it perfect. So I'm going to go back here, and I'm going to go -30 decibels to +30 decibels. I think that'll do it for my setup anyway. And look at that. So the background noise is almost nothing, and the only you know, pixels with any intensity this is a much clearer representation of my voice as we're listening to it right now. So I actually like this. I mean, this is pretty dope. I like this. I don't see myself changing it from here. I really like this. This looks like an extraordinarily clear signal. So yeah, we cleared that up, and it looks beautiful. And you can see as well, if I try and, I'm going to try and sing, which I shouldn't. I'll try and hit like a note, like a he. Oh my god, that was so bad. But you can see that sort of, see these like almost like in harmony, these like different frequencies that are like fixed distances apart. So you can see there's a few more there. I don't want to do it. I'm way too embarrassed to try and sing again. But you know, you can see some really interesting patterns in this spectrogram. So yeah, we're gonna continue. And yeah, not much to go now. We're just gonna add a few details, a few things. We're gonna speed this up. That's one thing we're gonna do. We're also gonna add the time axis and the frequency axis. So let's keep going. One thing I want to do is see this. We're printing out. I don't want to print. I want to log. So get rid of that. I'm going to open up. I'm going to go to our app main, and I'm going to import our logger. And come down here, and I'm just going to swap this out. I'm going to go logger info. We're going to need a formatted string. There we go. Much better. It's pretty good. Yeah, and so if you like, there's lots of different sounds that have like definitely distinct, distinct patterns, which they're really cool. I've played around with this a lot. I've seen, I've tried to sing, I've tried to whistle, I've tried to, all sorts of stuff. Okay, so there's one other thing I think I forgot to do earlier. Remember when we go to our window and see we created this exit. So I want to implement this exit, and I want to clean up our source when we close. So I'm going to go here, I'm going to go exit, and I'm just going to go self.source.release. Save that, and we go back to we're going to go over to our source. Let's make sure we've implemented that release function, which we have not yet done. So in here, that should work. And I'm going to take these functions, these logs, and I'm going to stick them in here. And I'm going to do the same thing with our size. And the same thing with our init as well, just so that we don't lose those logs. Cool. Now when we go again, sweet. Now if I scroll up, you can see, our init, and then all this comes from our initializing our PyAudio, and then so